Comparing different representations of a function. We have learned how to represent a function in several ways: as a table or ordered pairs, as a graph, as an equation, or as a verbal description or scenario. Next, we will compare two different models to each other. We will look at the relationship between the two models in terms of the rate of change. In order to compare the rate of change of two different types of representations of functions, we simply find the rate of change of each function and then compare them. The higher the absolute value of the rate of change, the bigger it is. So for example, if a graph has a slope of -4 and an equation has a slope of 3, it doesn't matter that the number 3 is greater than the -4. It's the fact that the slope of the graph is actually steeper, the slope of -4, because the absolute value of -4 is equal to 4, and the absolute value of 3 is equal to 3. And 4 is greater than 3, so the graph has a bigger slope or rate of change, therefore making it steeper. Let's look at an example where we actually have to find the rate of change or the slopes ourselves. We're asked which has a greater rate of change, the equation A or the graph in B. So with an equation, we can find the rate of change by finding the slope by looking at the coefficient of x if the equation is written in slope-intercept form. If the equation is written in y equals mx plus b, the slope is the coefficient of x, and our equation is written in that form. The y is by itself, so the slope we can see is -5. Now the graph, we have two options to find the slope. We can either count the rise over run between points on the line, or we can pick 2 points on the line and use the slope formula. Because we have 3 very distinct points on the line, I'm going to use the rise over run method. I'm counting from point to point that they move up to right 1, up to right 1. So our slope is +2 over 1, which equals 2. So now let's compare the two slopes. We have the slope of A is -5, and the absolute value of -5 is 5. And the slope of B is 2, and the absolute value of 2 equals 2. So comparing the absolute values of the slopes, we have that 5 is greater than 2, so it shows that A has a greater rate of change than B. Now let's try to compare a table and a verbal model. We have the verbal model in A that reads, Chris and Shari are going to have a bowling party. It costs $10 to rent a lane and $2 per pair of shoes. And then B is our table. And again, we want to know which has the greater rate of change. First, let's start by finding the rate of change or slope of the first verbal model function in A. We can actually turn this verbal model into an equation. So we're told that it costs $10 to rent a lane, so 10 is a constant fee. We are then told that it costs $2 per pair of shoes to rent, so the 2 changes depending on the amount of people at the party. So the equation is going to be y equals 2x plus 10 from y equals mx plus b, where a constant amount is going to be b and the changing amount is going to be m. So what is the rate of change? Now that it's in that form, we can see it's the coefficient of x. We can see that the slope is equal to 2, so the rate of change is equal to 2 for that first function A. Then we have the table. So to find the rate of change in the table, we can use the slope formula. We can pick any 2 points and calculate the slope, and then we'll be able to tell which has a greater rate of change. So we're picking randomly the 2 points, the first two, 2, 7, and 4, 13. And using the slope formula, y2 minus y1 over x2 minus x1, we get 6 over 2, which equals 3. So the rate of change of the table is 3. Before we found the rate of change for the scenario, once we turned it into an equation, was 2. Then the rate of change of the table is 3. So A equals 2 and B equals 3, those rate of change is this. If we take the absolute value of 2 that still equals 2, and the absolute value of 3 still equals 3, and 3 is greater than 2, so therefore B has the greater rate of change.